In today's era, we're moving at a rapid pace of development and innovation. Parallel to that, a growing dependency on fossil fuels and an increasingly capitalist system. As we covered earlier in the semester, we're approaching a tipping point of no return, and radical change is needed now. As planners and designers, we're lucky to be in a position for real change. There are many ways we can approach that. For example, we can look to buildings' efficiency and performance, its low carbon source of materials, its heritage and cultural consideration, and many other influencing topics, which require more integration into teaching frameworks. But there's one that I feel not a lot of us know how to approach. That is biodiversity. Animals can communicate with us, so it's up to us to do the research and thinking for them. How will our buildings affect their homes, their gardens, their lives? We're on this earth with millions of species, not just our own, so we need to be considerate of that. So how should we approach it? Well, in terms of design strategy, everyone's different. But if you want to implement a biodiversity framework into your approach, you can try an AA approach. That stands for Assess and Adapt. This approach uses a series of acronyms to help you remember key points for each topic. So starting with Assess, Assess is defined by the acronym RULE, or U-L-E. OR stands for Research, Research and More Research. Read up on ecology and biodiversity. This step is one that you're going to keep coming back to because you should never stop expanding your knowledge on the topic. As the two worlds of architecture and ecology will combine further in the future, better information will surface, making this redundant. But it's all about starting and continuing to grow that bridge between the two. So where do you look? Or how do you start? Well, start anywhere. A good place to always come from is to think in terms of the animal or plant you're trying to aid. Try and see it through their perspective. In many cases, that's more than one. So look up local flora and fauna populations and some of the regional endangered species. So an example could be if your site is in a region with a lot of bird presence, research bird patterns, the local biodiversity reports, and understand different bird habitats and see ways that if a built structure you're adding can aid rather than impact negatively. So get creative with it, but stay informed. So to summarize, OR stands for inform yourself with as much research as you can handle, because all good decisions are informed ones. U stands for understanding. Understand the space you're working with. Again, continually going back to OR. This is the point site analysis would be occurring within your design studio stage. So running parallel to that, things you could do would be further research into the local biotope. Where does it sit topographically? Is it on an open or closed site condition? Is it near any other patches of greenery? And to locate these nearby areas and speculate lines of connectivity between them. Site visits or fieldwork, as with any site analysis, is very important. You would ideally visit the site as part of your site analysis, but what would separate a site visit from fieldwork would be visit the site regularly, in varying conditions and noting different aspects each time. So when you visit the site, your analysis can be split into three. So remember the acronym SET, S-E-T. S stands for survey. Try to note and take photos of any flora or fauna you see present in or around the site. Each time you visit, this list will grow and informs decisions further down the line. E stands for existing. What things can you look for in terms of improving biodiversity? Are there already things on site that would help it? And try to keep and integrate them. So E stands for whatever's existing on site. T stands for tone. What's the tone of the site and what are the conditions like? Is it windy, cold, warm, wet, noisy, claustrophobic, isolated? Are there any natural cycles occurring in or around or even through the site? Is it sitting low or high topographically? And what flows into it when it's raining? Remembering the important aspects that you might consider to retain on site can be difficult to remember. So use the acronym WORLD. W-O-R-L-D. W stands for wetlands. Are there any naturally soggy areas that water rests and sits? O stands for outcrops. Are there any rocky outcrops that are on site? As these usually contain great aspects for biodiversity. R is for remnant patches. Are there any small patches of natural greenery like small ecosystems or wildflowers present on site? L is large green spaces. When working with a bigger site, are there any large green spaces? This might be a space to consider retaining as local fauna have become accustomed to it. D stands for drainage lines. Are there any streams running through the site? Any running along or near it that can connect it to other green spaces? In heavy rainfall, where on site is the water channeled or run along? Drainage lines are a good place to start when you're looking for added connectivity to other green spaces within the urban framework. So remember, WORLD stands for wetlands, outcrops, remnant patches, large green spaces and drainage lines. So moving back to RULE, L stands for liaise to learn. Talk with ecologists, environmental scientists and zoologists. Start this conversation and learn from them. As we aren't experts in this field, Gathering as much expert insight as possible and building on this cross-disciplinary exchange will increase its integration into architecture. Finally, we have E. E stands for evaluate. Evaluate all the information and research you've gathered in the assess stage. This is a good point to take note of everything you found. Make lists of any flora or fauna populations you found on site, and note anything you'd like to retain or add within the site. Since gathering an understanding of the site, the adapt stage would begin. This stage is in parallel to the initial design schemes you generate within the first week or week and a half of a design project. There are aspects you can follow that can help you inform your design studio and aid its overall biodiversity. Before moving on to the adapt strategy, it's necessary to understand a few ecological principles. In ecology, we have abiotic and biotic factors. Abiotic factors are non-living aspects to an ecosystem that shape an environment, whereas biotic are living aspects that affect an ecosystem. Abiotic is the most important aspect here initially, because they essentially describe the suitability and potential of a site. Abiotic factors are those that are naturally occurring. It's important to note here that there are aggressive and weak abiotic factors, and that aggressive factors are dominant over weak ones, so noisy over calm, saltwater over freshwater, dirty over clean, mineral rich over mineral poor. A lot of different species can grow in weak abiotic conditions, whereas very few species can grow in aggressive conditions, so it's always favoured to have more weak abiotic conditions present. So with this in mind, it's beneficial to create an ecological system that's complementary to this. In developing a biodiversity site strategy, creating a stable gradient allowing water to flow from nutrient-poor, clean water to nutrient-rich, polluted is crucial. An example of this could be if you had a site with a road running adjacent to it. For biodiversity, you would want a gradient to fall down to the road, rather than up to the road. This is because, if the latter, the polluted rainfall from the road will fall into your site, creating this dirty to clean gradient, leading to it being dominated by these aggressive abiotic conditions, and very few species the possibility to thrive. Another not so apparent strategy is buffering, again creating a stable gradient from clean to polluted. So having soft edges of greenery from your site spaces to the more urban edges will help soften this gradient from clean to dirty. This strategy can be systematic in many ways, but the key is a stable gradient from clean to dirty. This is a crucial aspect to be aware of, because if aggressive conditions sit at a dominant geographical location, whether that's just uphill or further upstream, it will negatively impact the biodiversity of your site beyond your control. So, moving on to the adapt stage. Adapt is defined by the acronym ASSUME. We've all probably heard the meaning for assume, that it makes an ass out of you and me, but when we use it here, it's on the contrary. We don't want to assume anymore, we want to help. A represents abiotic. What are the abiotic conditions? Are they aggressive or weak? And are there any possibilities of a dominating nature in terms of cycles or topographies? This is where you will identify and create a master plan for a clean to polluted abiotic gradient system, thinking locally but also regionally. S is for site. In tandem with the gradient master plan, what aspects on site are you going to retain? What are you going to add? How are you going to increase the connectivity? Urban ecosystems can be very fragmented, but connectivity helps improve both local and site-specific biodiversity. So creating lines of connection using both natural features like streams, hedgerows and grasslands, or man-made features like green roofs, blue-green infrastructure and green corridors in cities really helps. This will allow both mature and juvenile species to move about the local biosphere and establish new regions and habitats, as well as creating a more complex and comprehensive urban ecosystem. S is for species. From the catalogue developed in Assess, you would have a good understanding of the local flora and fauna. It's important to identify these and be aware of regional trends and biotopes. All of this will inform your species selection for on-site. It's always preferred to use species already present in the locale, as using contrasting species that are not indigenous to the area can lead to ecological sinks and traps for native species, so it's generally good to stick to native and ideally local organisms. U is for understand. Throughout the whole process, try to understand the conditions from the animal or plant's perspective. Put yourself in their shoes. They can't build or design or communicate to us, so we have to understand what it's like and think on their behalf. M stands for make and manage. You shouldn't make if you can't manage. That means post-construction there needs to be a management system in place, because although the adaptation of the site is there, maintaining and managing it is where the difference is going to occur. The management is considered the process, whereas the adaptation is considered the space, and the process over time dictates the space. E is engage and educate. A community and public engagement into this initiative is vital, as it feeds into this management aspect, and engaging naturally educates and motivates people to become interested in the topic of biodiversity and further spread the word. In remembering the entire AA strategy, the following sentence can be used. Assess that we don't rule the set world. We must adapt so that we no longer have to assume.